Afternoon, everyone. Hope you are doing very well. In the previous lecture, we discussed the abstraction concept. In this lecture, we're going to be focusing on encapsulation. What do we mean by encapsulation? Well, in simple sense, you're encapsulating something so that, say, for example, you have a bag, and inside your bag, people who are looking your bag just from outside, they don't know what is inside your bag, just a bag. So what you did basically, you have encapsulated your books, your money, or whatever is in your bag, you have encapsulated those details, fine details, in a bag object. All right. In the same way, when we talk about systems, objects, so encapsulate means that the details are hidden inside the object. Okay, so it's sort of at a different abstraction level, those details may be visible, but at another abstraction level, those are hidden. Okay, so it's a relative term. And abstraction focuses on the outside, how the object looks like, boundary of the object, doesn't focus on the fine details or implementation. Encapsulation, on complementary side, focuses on how to implement that particular object. So it's like a macroeconomy and microeconomy, where my macroeconomy focuses on big things, say government policies, interest rates, whatnot, macro factors. And on microeconomy, okay, tomorrow what the stock price gonna be, for example, at a micro level, or your investment portfolio in a particular, uh, sectors, securities, for example. So let's go back to our favorite example, okay, the happy dog, right? See, cute looking happy dog, smiling, with the big glasses, sort of glasses, I have put it here, and happy face, right? So what encapsulation means, that it is basically the hide the details of this dog object. Okay, so you don't know what is inside the skin of the dog until or unless you tear the skin apart, or or you do operation of the dog, and then you see what is inside it. But on a outside world, at a outer level, it's just an object, and you identify that object, that okay, this object, you may name it, puppy or Sam or whatnot, your own favorite uh, doggy name. So it's a class of animal, we call it dog, and you may give a different name to that particular dog to identify it as an object. Okay, so encapsulation, remember, the key word here is the hide the implementation details, right? We discussed another example of a digital pen in previous lecture. So at abstract level, we just see the pen, but we don't see what is inside the pen. Okay. So let's see. Dog may have a heart, right? Or may have some other um, parts. For example, if dog is not live animal, it might represent a abstract concept of an object which may have parts, say uh, an animation object on your computer screen, or a character in a computer game. So that may not have heart as such, but may have other implementation details. Okay, in the same way, your digital pen may have integrated circuit, okay, IC, inside it, which gives you the functionality of which gives you digital functionality, or functionality for, let's say, Wi-Fi transfer of the data. Okay, So that's sort of, that this object is encapsulating all different parts. So here I'm just, to make you understand, um, giving simple examples, but it may be complex, objects may be complex, and how they are interacting with each other. So what essentially we did, we did hide um, the implementation detail, for example, heart or other parts of the dog inside the skin. Okay, same way we have hide the integrated circuits or all digital components, inside the body of the pen, and at the abstract level we just see the digital pen. Okay, what it is, encapsulation focuses on implementation that gives the observed behavior, okay, as we have as we see or identify when we analyze or apply the concept of abstraction, right? So this pen, for example, it may have the IC made by, who knows, um, you may choose uh, who is the manufacturer of this IC. So you might decide to go with your implementation engineer might decide to go, no, we don't want to use this X company's IC, we want to use Y company's IC. But so you have given them the independence of choosing the internal part of this digital pen. And as a system architect level, you are just focusing on an abstract level. Okay, we want a digital pen. How it is being implemented, what sort of ICs we're gonna put it in, and what sort of cartridge we're gonna put it in. That is that you are not focusing, that your implementation team is gonna focus. So what it is, it gives you freedom, okay? So it localizes the design decisions which are likely to change and gives the implementation team the freedom to choose how to implement, okay? Right? So you may think of many other examples. Let's say you said, okay, we want a pen, digital pen with the functionality that it can write and it can transmit the data through wireless. Okay, your implementation team says, okay, instead of this yellow color, body part, we can replace it with gold, okay, or some other metal, for example, until or unless you yourself are a design at a design level engineer, that you are more focused on how it looks from outside. Okay. So at different level of abstraction, different implementation details are visible. So remember, these are abstraction and encapsulation. These are complementary concepts. It's not that you are drawing a fixed line. No, it's just at a different level of abstraction, different things are visible and different things are hidden. And that we achieve via the concept, or we apply the concept of encapsulation. So remember, these are the concepts to help a system architect or ourselves uh, in thinking in terms of object oriented design. Okay, and then we're gonna how we can effectively design our system. All right, thank you guys. Hope you have liked this lecture. Thank you for subscribing, and those who have not subscribed, please do subscribe. We appreciate your feedback and your wonderful comments. Have a wonderful day.